All right, hello there, and welcome to our AWS Made Easy Ask Us Anything live stream. This is episode number 3. We're doing a weekly series Tuesdays at 9 a.m. So thank you for joining us today.
Hey
Before we
everyone,
start, how you doing, Raul?
doing very well. Looking forward to the discussion today.
Yeah, me too. We're going to try the different format of going over just what's new in AWS. And again, for everyone in the audience, please feel free to ask us questions about anything AWS or anything about anything. We'll do our best. And before we start, I'd like to thank our ASL interpreter, Erica. It's really nice to have you with us today. And also, one other thing to watch for, I don't know if you saw it in the comments, but there are 3 subtle sci-fi references in this live stream. So keep an eye out for those. Try and comment and see what they are. I thought, we make it fun and mix it up. So again, this is an Ask Us Anything, so we want to spend the time answering your questions, going over real AWS issues that you're facing. Whether you're just getting started or you have years of experience, we want to talk to you. All right, let's just catch up. How was your weekend, Ro?
Really good. For the audience, both Stephen and I are big Lego fans. We just spent the last 4 months working on that Bugatti Chiron. And that is an insanely complex piece. It took us about 4 months to build it. But really amazed at how much concentration it gives the kids. They sat for hours at end trying to put together these pieces, following hundreds of pages of instruction. So it was a really, really interesting learning experience for all of us.
That's incredible. I remember doing the original Technic supercar with my dad, and I think they've gotten, what would you say, at least two orders of magnitude more complicated?
I think so. I think these have gotten really, really seriously complicated. These ones you have to build the engine with all the camshafts, the transmissions, the differentials, steering mechanisms, all of that actually works on this car. So they've tried to make it very complex and as realistic as possible.
Oh wow, that's fantastic. Oh, we ended up going to the Marriage of Figaro over at the Seattle Opera.
Oh, that's pretty awesome.
It was really fun. Now, you talk about attention span. For me, like my 2 older kids, they love it. They were riveted the whole time. I mean, it was a fascinating story, but it was. I'm just amazed at their ability to hold their attention at this kind of complicated, convoluted story for a couple of hours.
No, it's fascinating. It's great exposure for the kids as well, to have them learn to go through these experiences. Definitely very, very enriching.
Yeah, it was a blast. And it's been a bit cold and rainy here, unseasonably in Seattle, but I imagine it's a bit hotter for you.
Pretty much. We had a little bit of showers over the last 2 or 3 days, but now it's back to being hot, sultry, and yeah, we're going to live through that for the next few weeks.
Oh, fantastic. Oh, all right. Well, should we dive into what's new in AWS?
Absolutely.
All right. So let's pull this up. We decided to pick out 6 different of the what's new in AWS. It's the keeping up with AWS is a bit like drinking from a fire hose, and there's so much going on and so many incremental changes to each one of their different services. So we thought we'd just go over a few of them and see what's happening kind of across the spectrum of AWS services.
Yeah. And by the way, for the audience, if there are other ones you want to pick out, you want to ask questions about some of the other announcements, like Steven said, it is really a fire hose that you feel like you're being bombarded by. And keeping track of all of that stuff is really hard. So we're just picking a few today, but we'd love for your feedback and we'll pick whatever you are interested in talking about.
Yeah, just post the URL in the chat and we'll just open it up right here and go. So the first one we wanted to look at, and this was posted on May the 4th on Star Wars Day. It's the Trusted Advisor. So just looking at the text, it's AWS Compute Optimizer adds 4 new AWS Trusted Advisor adds 4 checks automatically ingested from AWS Compute Optimizer. The AWS Trusted Advisor provides recommendations that help you follow AWS best practices. Okay, so it just kind of breaking it down into pieces. Compute Optimizer is analyzing your AWS workload, and it's helping you choose optimal configurations for, in particular, EC2, EBS, Lambda, based on your utilization. So say you had a very large instance that had very low but very predictable utilization. Compute Optimizer, it might tell you, hey, your instance is too big for what you're using it for. So how does Trusted Advisor and Compute Optimizer, what's the relationship between the two of those?
Yeah, so you should think of Trusted Advisor as your place to go for a lot of the AWS best practice recommendations for which they have built a bunch of finders. And that's the place where they bring in all of these recommendations. They have 7 core services or categories under which a lot of these insights or advisors are coming in. The services primarily are S3. You'll see security groups. You will see IAM. You will see multi-factor authentication, again, along your permission schemes. You'll see some recommendations around RDS, EBS, service limits, and so on. Broadly, I think the vast majority of recommendations that exist today fall under the security category. So even though they're across all of these services, I think the first ones they've focused on, and rightly so, are all the security ones where developers or customers end up leaving some loopholes in their accounts, whether those be don't log in with your root account kind of recommendations, use an IAM role for your services, use tokens that expire, on regular use and use refresh tokens to operate your services. Things like that, or don't open up everything to a CIDR of 0.0/0 kind of setup for your resources. Those are the kind of best practices that they put into Trusted Advisor. Now, over a period of time, what Trusted Advisor has been doing is been drawing from a bunch of other tools that AWS has built, and Compute Optimizer happens to be one of them. And where tools like Compute Optimizer help is they bring in certain insights that are related typically to cost and appropriate resource utilization. They initially started off with recommendations around EC2 instances, where they would take a look at your CPU utilization, memory, network I/O, and disk I/O, and make a few options as recommendations. And you could pick the one. Once you did that, it helps you run a few what-if scenarios to understand what might happen if you chose one of the 3 or 4 options that they provide. And that helps you make better decisions. Now, just to be clear, these are advisories where you still need to do a bunch of work. You still need to go look at those options, weigh those options, make trade-offs as necessary. You also need to make sure that you've covered some of the fundamental requirements. So for example, please, I request everyone, install the SSM agent in on all your instances. It doesn't happen by default. Install it so that you can actually start capturing memory metrics so that you can make better optimization decisions. Without simple metrics like that, it's really hard to make decisions around what the right size for your instance is going to be. The next thing that I recommend everyone does is really think about all the variables in making a change on these instances, because you have to think about what is actually running in there. Is it really stateless? Is there stuff that's in memory that's not yet being persisted on disk? Because when you change your instance type, you're going to have to take a snapshot, turn down your machine, start up the new instance, and then start using the new instance. So if there's stuff that's still in memory, that's not really persisted, you might end up losing it. So be cautious about all of those things. But if you actually get to the right resource utilization, I mean, you suddenly find that everything is far more performant. You've balanced, all of your trade-offs between different IOs, IOPS, CPU utilization, memory utilization. Everything just works seamlessly. So there's a bunch of that you have to do. The other area where we've actually found compute optimizer to be incredibly valuable is lambdas. Um, Really trying to figure out how much compute and memory you need for lambda functions is incredibly hard because it's serverless. You don't have control over the server. And you have to basically look at executions over a vast number of lambda calls. And what Compute Optimizer does for you is it actually does all that for you, does all the hard work, collects all of that information about how much CPU got used, how much memory got used, does all the math for you, and tells you what the right size for cores and memory should be. And they just announced a memory size over provisioning as one of the insights out of Compute Optimizer, which is awesome. They were doing CPU earlier. Now it's memory as well. So you get to optimize your CPU and memory and your lambda costs quite significantly.
That's okay. So just to recap, well, first, I really like the idea of having them focus on security first, because that's got to be the priority. But that being said, with Lambda, I've definitely fallen into this trap where when you're developing, you way over provision it, and then once you get the immediate task done, you can forget to then adjust it back down, and then you're ramping up this Lambda that's way too big for what you need. And then same thing with under provision. Say if you're using a Lambda function that's loading up all of your users or all of your transactions, and that might grow over time, and then eventually you're going to find that you're going to get that out of memory error, and you want to be able to catch that at scale. So what Trusted Advisor and Compute Optimizer are watching for these type of errors. So Trusted Advisor is, I suppose, the general framework of advice for managing your AWS account, and then Compute Optimizer is one of the sources of data that it can draw upon to give you that.
Correct.
Cool. This is I can see this being really, really useful, and helping people save on their AWS bills. Do you see EBS volumes being over or under provisioned? How do you see that kind of cropping up in practice?
So this is an interesting one. In my experience, I actually find that developers either operate in powers of 2 or powers of 10. So when they provision EBS volumes, it's either 8 gigs, 16 gigs, 64 gigs. They either go in those powers of 2, or they would do 10 gigs, 100 gigs, TB kind of volume provisioning. And to be honest, I don't think developers spend enough time thinking about how much disk space you actually need. On the face of it, it actually looks really cheap to take up 1 gig or 10 gig 10 gig or 100 gig EBS volume and just slap it onto your instance. But over a period of time, as you do a lot more of these, you suddenly find that you're wasting so much space on those volumes. It's just, you really never need that much. And in most cases, I've found volumes to be provisioned in excess of 10x of what they actually need. So there's tons of room for right-sizing them. And I think having Compute Optimizer do that for you out of the box is pretty neat. It's actually fairly straightforward also to resize your EBS volumes. So if they are small and you need to resize them at a later stage, you can actually do that with a very simple API call. So that's pretty neat. So it makes sense to right-size them at regular intervals and make sure that you have them running optimally.
Yeah, that makes a lot of sense in terms of, and I definitely fall into that habit of powers of 2 thinking. I was just thinking about when you make, this would be a pretty nerdy diversion, but when you make your RSA keys, you say, okay, I'll take the 4096-bit RSA key, and then I saw this advice once. It doesn't need to be that size. You can make it 3997. And so if there's ever a giant RSA rainbow table, you maybe you shouldn't do 4096 because that's where that search space is going to be.
Yeah.
And then definitely also, like you said, it's a couple pennies when you're dealing with one, but all of a sudden that one has become thousands and you want to right size.
Absolutely.
So I think our last question before we move on to the next one is, our sponsor is Cloudfix, and how does that relate to Compute Optimizer? At a first pass, where they're both looking at optimizing the usage of AWS resources, but how are they different, or how do they what's the Venn diagram?
So I think this set of recommendations are disjoint from what Cloudfix does. Cloudfix focuses primarily on cost advisories from AWS that are completely non-disruptive. So with literally a couple of clicks, you can start saving money without worrying about, restarting instances or something getting lost or, disruption to your service. These ones are disruptive because they either need an instance restart if you're talking about instances, EBS volume resizing, depends on the scenario, which way you're going, may or may not require you to detach the volume, work on it, and then reattach it. And then lambdas, when you resize them, may cause a little bit of disruption as it's kind of turning over, unless you manage, the mechanism by which these changes are being made. So I would say potentially disruptive and not, 100% safe. You do need to make some trade-offs at times. So the Venn diagram stands disjointed at this point between what Compute Optimizer is doing and what Cloudfix does.
Oh, got it. So the optimizer is saying, okay, here's some changes that you could make, but don't just close your eyes and push the button. Whereas Cloudfix really is, there's no disruption. You go ahead and do what it tells you to, and there's going to be no performance hit. You're just going to flat out save money.
Correct. And by the way, one other thing is there isn't one answer to these Compute Optimizer recommendations. Like if you go to the EC2 one, they typically will list 3 or 4 options with different profiles. Do you care about, finishing the workload faster? In which case, if you find that it's multi-threaded, they'll bump up the CPUs. You can probably resize to, compute optimized instances. Or if you, want to reduce your costs, it might be memory optimized instances. If your network IO and stuff are the primary drivers of it, you might decide to go with certain other kinds of IO optimized or EBS optimized volumes that go on those instances. So there are different trade-offs you have to make depending on what your motivation is for that workload. And that's not something that a machine can make, just out of the box. So given that, you as a human has to go in, you have to look at those options, make trade-offs, make a decision, and then execute on it.
Got it. Okay, so it really is in the true sense of advisor. It's giving you some advice, but it's not going to be the push of a button. You have to think about, okay, well, I have to make some changes in order to take this advice on notice.
That's correct.
Perfect. All right. Well, that was really fun to think about. It is pretty neat, just in general, thinking about how to more efficiently utilize these instances or these resources. All right. So the next one is, and this is a bit more specific, but it's fun to talk about the broader context in which that sits. So this is the ThinkEdge SE70 powered by AWS Panorama is now available for sale. So in order to discuss what this is, we have to think about, well, what's edge computing? And so edge computing is, for some applications, either due to just the bandwidth restrictions or the data governance reasons, you've got data that you want to do something with, but it can't leave where it is. And so an example would be computer vision in manufacturing. So you have this manufacturing pipeline, things are happening really fast. You've got an IoT device like the SE70, which is taking a photo of this thing, and you want to run some image recognition on it, but manufacturing is fast. It might be hundreds per second. So this is where you'd want to use something on the edge. I'm going to show a video of where this fits in. I thought this was pretty neat. So what this is doing, that's a recycling center, and they're taking pictures of the different bottles, and then they're using machine learning to sort and specify the bottles into different types of plastic, and then that's this is then, how do you say? Yeah, it's sorting it into different types of plastic, and that makes the recycling more efficient. But they couldn't take a picture and then send it all the way to AWS. They're doing, one bottle every 10th of a second. So that's too slow. That maybe if you had a great internet connection, but you still have to send the image to S3, make an API call, process the result. So you'd want to do that in real time. So, Ro, where do you see edge computing fitting in?
Yeah, so I think the way you should think about edge computing is there are certain scenarios where the cloud compute infrastructure has to kind of extend to the edge because of constraints around bandwidth and latency. You have to have considerations around where your what the workload really is and how much data are you actually ending up processing. There are times when the sheer volume of data that you're processing is so large that there's no way, no matter how large a pipe you have connecting you to the cloud, there's no way you can go stream all of that data. To give you an example, and that's kind of a lot of the work that Panorama is doing. For more details, by the way, there's a amazing podcast that I did with Omar Zarka, the GM of AWS Panorama, just a few weeks ago, as he talks about where Panorama, excels in edge compute and the kind of use cases that they've been working on. But I'll try and cover some of that over here.
I'm going to put the link to that in the chat.
Yeah, that'd be awesome. So
there it is.
Some of the examples that Omar was talking about in that particular episode was they've got warehouses, they've got big supply chain and logistics partners where what you have on premise is all of these CCTV cameras that are literally monitoring and managing everything. But that data is not being made use of at all. And with this edge appliance that they have, you can actually take machine learning models, deploy them on the edge remotely from your AWS console. You can deploy them on the edge. And you can now literally just connect your cameras, your IP cameras. You don't need to change any of your infrastructure. You don't need to change any of your hardware. Just add this new appliance to your rack and start put them in the same network as your cameras. Start getting data streams from your cameras, and then you can start applying machine learning models to whatever is happening over there. Some use cases were pretty amazing. In certain hospitals, they are looking at cases where patient care. Some use cases around patient care, like making sure patients don't fall off their beds or predicting if a patient is likely to fall off their bed while they are in hospital. Things like that are really remarkable use cases. I think Omar was talking about another case where on remote farms, sometimes the people who are actually inflicting cruelty to the animals the humans are responsible for inflicting cruelty to animals, but to be able to detect that remotely and using machine learning models and act on it immediately is something really remarkable. To understand, what's happening around security, logistics, where every package is, or where shipments and containers are moving in massive dockyards. Those are all use cases that Panorama is now enabling. And having this new device that's now available at a lower price point is pretty amazing. So the original AWS device that they came up with, that AWS has, was based on the Nvidia Jetson AGX Xavier processor, which I think you have that over there. So that's the Xavier NX. The AGX is what goes into the AWS built device, and that has a lot more throughput and a lot more bandwidth to basically add, if I'm not mistaken, he set up to 8 to 20 cameras, but it also depends on what kind of models you're running. So how much CPU you will actually end up utilizing for your machine learning models. But these other ones, the new ones that have just been launched by Lenovo, are pretty neat too.
This is some powerful kit here. So 384 Nvidia cores, 48 tensor cores, 6-core. We've got the Nvidia Arm, and then also they're hardened devices. If you look at this photo, they're fanless design. They're industrial application. Like you said, could be used in a loud, busy factory floor or farming applications, and being able to have that image recognition right there. And also, you mentioned medical, right? This can do image recognition or voice recognition where the data isn't leaving the premises, which is really important in some of these regulated environments. But you can still take advantage of AWS's scale in developing these large models. That's pretty neat. I wish I personally had an application for this where I could. I think for me, a Raspberry Pi or an Arduino is probably going to be sufficient. But if I did have a factory, I would definitely want one of these.
So I actually ended up getting one of these Jetson Nanos, and I'm still working on some machine learning model around the security in my house. I have 11 cameras around my place, and I'm looking forward to experimenting with the Jetson Nano to see what kind of models I can come up with.
No, those Jetsons are really neat. I did some work with a drone company once and was trying to get one of the Jetsons up in the air. they're a lot of fun devices, and especially that versatility of ARM. It really shows the versatility of the ARM platform. It's funny just thinking about this in the context of factories. It's amazing how much those have developed. I love just watching these factory videos. There's a subreddit called Automate. And so when I first thought of factories, this is what I always thought of. All right, did anyone catch where this particular factory comes through? And it is amazing the kind of the speed and the throughput of these. So this is from the 80s, obviously, but then when we think about what's happening these days, it looks more like this. So this is a pick and place machine where it's taking these 1 millimeter components and picking them up off of these strips of resistors, strips of capacitors, and it's picking them up, taking a picture, figuring out exactly where it needs to be, placing it, and this all has to happen really, really fast. And then this is a circuit board that's going to be made, and this circuit board can then pass by an edge device, and it can do something like defect detection.
Yeah, there's actually some really interesting work being done in defect detection, where there are some, like if you look at Lookout for Vision as one of the AWS services, I think if you give it something like 10 images of just for training of defective and non-defective pieces, it does a pretty neat job of identifying anomalies or defects for all future pieces and parts that come through the line. So check out AWS Lookout for Vision as well. It's a very, very neat service in the manufacturing and industrial space. If you have a use case, we'd love to know. Yeah.
Awesome. And I like how AWS, and we'll see this again with one of the other things that we're going to talk about soon with EKS Anywhere, but they really have this continuum of edge to cloud.
Yeah.
We got a question from the audience that I think we should talk about. Let's put this on the screen.
So I think the question says, in what situation would you recommend using an auto-scaling EC2 volume in a cost reduction perspective? So I'm a little confused, to be honest, by this particular question. I'm wondering if it is EBS volume or are you talking about auto-scaling EC2? Because those are two different things. But let me talk about using auto-scaling EC2 instances. I think that's the right way to do it, because the whole point of leveraging the cloud is that you have elastic workloads, or you have elastic compute being leveraged to perform processing on your workloads. So as long as your processing is going to be elastic, where it scales up and down depending on how much workload is coming in, you actually optimize on costs. So auto-scaling groups, leveraging them should be kind of done by default. It requires you to rethink your core architecture. You can't, statefulness doesn't really work with autoscaling. It's got to be fairly stateless to operate. So if you have stateful workloads or stateful processing happening within your processors, that's going to be tricky. You have to figure out how to extract that out and make it stateless. Because once you do that, then you can auto scale up and down and not have to worry about managing state. There are some workarounds. We're going to talk about EFS shortly. One of the ways to manage some of the statefulness that exists in file systems. But in general, I think statelessness is where you need to be in the long run. And yeah, and then EBS, we don't really think of EBS volumes as auto scaling. You can resize EBS volumes as and when you need it, which is actually a really handy thing. So my only advice there is have regular checks, set thresholds for your EBS volume limit. So for example, as soon as you hit, you want your EBS volume to operate between 60 and 80% resource utilization or space. So have a trigger at 60, have a trigger at 80. When it approaches 80, or just as soon as it crosses 80% as threshold, trigger an API. It resizes your volume to go up to a point where it comes back to 60. If it drops below 60, have a trigger that will resize it down so that the utilization is 80 again. And you can do this with a very simple Lambda function that calls the API to do the resizing.
All right. Yeah, I really like that idea, and thanks. That's a great segue into EFS, right? Where EFS is this persistent file system that can hold the state, but then the actual EC2 instance that's working with it, that can be ephemeral. It could vanish or be replaced with a bigger one as needed. And I like that idea of, in general, just dealing with this, being able to leverage the cloud to scale up very quickly. This would be another kind of good old tech reference, but we used to talk about websites getting /dotted, meaning you have your website, it's running on your little Pentium Pro 200, and it's fine 99.9% of the time, and then it makes the front page of /dot, and all of a sudden you get this 10,000-fold increase in traffic, and it goes down. And so it's really neat that we don't really see that much anymore. Like if something shows up on Hacker News or still /dot, usually that they're hosted in a way that they can scale up to meet demand, and it works. So for this one-time 10,000x surge in traffic, it'll handle it.
Yeah, absolutely. And I think the cloud and services like AWS have really made that possible. Managing it yourself would just be too hard.
Yeah. All right. Let's go. Oh, hold on one second. Alice, I'm talking right now. Can you talk to Mom? Hello. Sorry, I got a little visitor. My 2-year-old daughter Alice came to say hello. All right, let's talk about EFS.
Great.
All right, so EFS now supports a larger number of concurrent file locks. So this is a really important one. So for background, like you said, EFS is the elastic file system. And the idea is that it can persist and share data amongst serverless EC2, amongst serverless applications. So whether it's an EC2, a Lambda, container in EKS, or most other compute services, they can use EFS so that you can have this very short-lived compute paired with very long-lived storage. And so today, the number of concurrent, the announcement today is, well, let's read it right here. Here's the big part of it. This update increases the number of simultaneous file locks to 65,536. So again, that powers of 2 from 8,192. And this means that EFS can be used for a broader set of applications that are using file locking. So where this comes down to, there was this great blog post I was reading, and it was called "The First Limit You'll Hit on AWS EFS is Locks." Put this one in the chat because I thought that was pretty good blog post. But it seems like it's so many files. But then where do you see this? Limitation being hit? The example that the blog post gave was databases.
Yeah. So just for some background and context, those not familiar with EFS, EFS is, I mean, think of it as AWS's version of providing some service like NFS. And there are two areas where you end up needing something like this. The first one, like I said, was you want ephemeral compute, where compute is, short-lived. And for example, you need tons and tons of compute to do something, but you don't want to spend an insane amount doing that. So you want to use and leverage as much of spot instances as possible. But the drawback of spot instances is that they can get taken away at any point of time. But spot instances could be 90% cheaper than your on-demand instances, right? But then it comes to state. Where do you store state when you're processing tons and tons of workload? You either store state in a database, but a lot of older applications stored state in the file system. Like you took some data, you did some processing, and you dumped it back in your file system, right? So the file system was one of the mechanisms of storing state. Now, when you don't have something like NFS, you only have EBS volumes. Your file system is local to your machine, your instance, right? The only way you can take that data and put it somewhere else is either detach the volume and attach it somewhere else, or actually try and do some kind of live transfer, from one instance to another. And when everything is ephemeral, orchestrating that is an absolute nightmare. So EFS comes as an amazing bridge that helps you resolve that gap in being able to deal with some of the older workloads that still don't use things like object store, or required to use the file system. I'll give you an example of a place that we started using EFS very extensively. Today we manage about across the entire portfolio, we have about 2.5 billion lines of code that we manage, and they're all in Git repositories. We have, I think nearly 100,000 Git repositories, if not more. I've forgotten how many there are now. But one of the things that we do as part of our analysis, whenever we acquire a company, whenever we are really trying to understand what's happening with our code bases, is we always want to know how we got here. Typically, the companies that we acquire are 10, 20, 30 years old, and they have tens of thousands of commits, if not hundreds of thousands of commits across different branches. So one of the most important things we try to identify is how did we get to the state of the code base that we acquired? So we literally start analyzing the code from commit number 1, and then go down commit after commit to understand what changes got made, what technical debt got added at what step, why did it get added, what was the evolution of the different features. And so you have to do this commit by commit across hundreds of thousands of code bases. So you want ephemeral compute to do all of this. Unfortunately, because this is all in Git, we couldn't use S3 as a processing mechanism because Git operates on a file system. You can't run Git on S3. So we were limited by the fact that each commit is very beautifully packaged in your Git repository, but it always runs on a file system. So we needed some sort of a file system to operate on, and EBS wouldn't work because the average Git repository that we have is about somewhere around 5 to 6 gigs. So every time if you needed to take the 6 gig repository and split it out across 1,000 compute units, you're copying 6 gigs 1,000 times. And that is not cheap, and that is not fast.
And so you can have this, that's incredible. So 100,000 repositories, average size 6 gigabytes, and you can have them sitting there ready to be accessed by Lambda, by Spot instances, by anything you want to, and you don't have. And it seems like EFS has really, made sure that it's accessible by the majority of these compute services. That's a really impressive thing, and it's really nice to know that you can use that. And that is an interesting instance where you said you need a lot of files.
Correct. We need tons and tons of files that we write to, because those. So you should think of it literally as a pipeline of processors that's just running, step after step. And so every step writes back to EFS with some of its analysis. And then other processors pick it up because they pick up a commit, they pick up the previous analysis. Because invariably you need to do a diff between your previous analysis on the previous commit and the current analysis that you just got on your existing commit. And then you do a diff, you write that as analysis for the next step, and so on. So locks started becoming an integral part of what we had to watch for. We actually ended up, even though we were using lambdas and we were using spot instances for managing all our compute, we were limited by the number of locks we had, because that was literally the number of lambdas you could run, or that was the number of spot instances you could run, or that many jobs that you could run at the same time, because all of these instances are holding onto locks. And if you increase the number of, if you grew your compute beyond that limit, you would basically start, throttling. You start receiving tons of errors, and you would have to throttle your entire pipeline. So
you're saying
that's actually awesome news that it's grown.
So if you were to do this today, you could do it 8 times faster.
Absolutely. We could do all that compute 8 times faster when we acquire a company, which is awesome. Because right now it takes us a few days to finish processing, in some cases, nearly millions of commits.
Well, I think that we need to do a separate episode solely devoted to this, the architecture of this this code analysis, because this is really fascinating. I think it would be a really fun episode to deep dive into that.
Absolutely, we'd love to do it.
And then just one more thing. I guess this is not the first time EFS has done this big magnitude increase. I mean, usually you don't get an 8x boost very often. So congrats to the EFS team for launching this. I guess in 2020, they did a 400% increase in read operations per second. So they're really pushing the envelope in terms of performance in leaps and bounds.
Now, actually, EFS, given the old architecture of NFS, is one of those services that has so much room for improvement in a cloud-native environment. Like, you can start rethinking what it means to build storage that is accessible across multiple computes with multiple writes happening at the same time. You can truly build it in a cloud-native manner. So there's tons of headroom to grow.
Yeah, absolutely. Yeah. Hold on one second. Alex, can you go to Mum for a moment? I need 20 more minutes. Okay, see you soon. All right. Well, let's move on to Amazon Lex. All right. So Amazon Lex, I think the Lex is, this is their service where you can build conversational interfaces into any application using either voice or text. And I think the Lex is the part of Alexa, right? That part that can do voice recognition. Now, whenever I think about voice recognition with computers, this scene comes to mind. So I'm going to put this on the screen.
It is a fine place you have here, Dr. Nichols.
Thank you. And I must say, Professor, your knowledge of engineering is most impressive.
Yes, back home we call him the miracle worker.
Indeed. May I offer you something, gentlemen?
Dr. Nichols, I might be able to offer something to you.
Yes?
I know.
Let me fast forward a little bit.
Glass need to be at. I were to show you a way to manufacture a wall that would do the same job, but be only 1 inch thick. Would that be worth something to you, eh?
You're joking.
Perhaps the professor could use your computer.
Please.
Computer? Computer? Hello, computer.
Just use the keyboard.
The keyboard. How quaint.
So I think it's a universal truth in science fiction that the future of interaction with computers is voice driven. I think we've seen that a lot, and it's nice to know that we're moving closer to the world of the Starship Enterprise every day, and I think Lex and things like it are going to be one of those building blocks that make it possible. So, pulling up the announcement again. The idea of Lex, before this, it used to be recognizing English generally, but English is really, languages in general are interesting because we get these domain-specific, um, how do you say, languages that evolve in these particular contexts. So, one of these, an interesting example of this, I guess a fun example is in American diners. There's this thing called diner lingo. And I'm going to put a link in the chat about what this is. But the idea is that there's this whole language that's evolved in American diners about funny names for food. And I'll play an example.
2 eggs scrambled on toast.
Sure thing, honey. Adam and Eve on a raft, wreck 'em.
I'd like a hot dog with ketchup and some Jell-O, please.
Paint a Bow Wow red and a side of nervous pudding.
Can I have a well-done burger with lettuce and tomato?
Burn one, drag it through the garden, pin a rose on it.
So that's a custom vocabulary, right? That's a set of words that only make sense in a particular context. And so if you were to build some chat bot or some special Alexa that could recognize speech and take orders in a 1950s diner, what you'd do is you'd build up this customized vocabulary where it would understand what you're talking about. And if you look up this blog post on Diner Lingo, it's truly unique set of phrases that wouldn't make sense in any other context. So what other good uses do you see for this one, Raul? And I'm being conscious of time because we've got 2 more that we want to talk about, and we've got about 12 minutes left.
Yeah, so I'll run through this very quickly. Lex is actually one of those services that I absolutely love. If our audience hasn't looked at it, I'll break it down very simply. Lex has this concept of an intent. An intent is basically what you intend to do. And an intent is constructed of basically the set of phrases that you might say and a bunch of slots. Think of slots as variables, right? So, for example, you might want to ask a question like, book me a ticket from LA to New York on the 25th of December, right? If you had a phrase like that, that's your intent. Booking a ticket is your intent. The utterances are book me a ticket, or you have 2-3 different kinds of ways of saying it. And then your slots are your origin, your destination, and your date, right? Those are your variables. And so Lex does a brilliant job of resolving that. Sorry, go ahead.
So for my diner bot, my intent would be order breakfast. And if I said, and I'm going to put this phrase in the chat, Eric, I have no clue how you're going to translate this one. But if I said, cowboy with spurs, make it cry, extra axle grease, and a mug of Merc, those are going to fill my slots. And what I'm really saying is Western omelet with fries and onions, that's making it cry, some butter, the axle grease, and a black coffee, the mug of Merc, right? And that's so now instead of having to have the teach a different vocabulary to this bot or to the people interacting with the bot, they can use the familiar vocabulary, the diner lingo, and Lex will know, okay, I know this body of words that I'm searching, and I'll fill it in for. I know that I'm looking for mug of Merc and axle grease and make it cry, all kind of these funny phrases that wouldn't be used in a normal English conversation.
Absolutely. And actually, one of the things that I really love about Lex, and I wish more people would do this, is whenever you're building an application, you invariably get inhibited by the UI and the UX you have to build to figure out how customers can access a set of API that you built. Engineers are really good at building API because they are to the point. The function or that API call does one thing. It has a set of variables that you pass it as parameters, and it produces an output that you can consume, right? But for an API to be leveraged, you have to build this whole massive UI and the UX around it to make sure that people find that API call, they know how to get it, they know how to pass, do the right things to get the right parameters passed to it, and then make sure that the data is presented back to them in a manner that is digestible, consumable, and all of that stuff. The conversational bots that you can build with Lex are amazing because you can literally build it to do one thing and one thing really well, which is do the job that the API does for you. So you can ask a question. That question maps directly to a single API call. The slots in your intent get passed in as parameters to that API call. Whatever the output is goes directly in your chat, client, and you get the answer then and there. It's probably the easiest way with the least amount of friction that you see in UIs and different kinds of UXs that people have built over the years. It's probably the easiest way to get to what you want to do with a whole bunch of applications out there, especially when it comes to data analytics, data analysis, slicing and dicing stuff. Using a chatbot to do it could potentially be revolutionary.
Absolutely. I think it's really neat that you can, if you can figure, and like I said, Lex right now, it's not artificial general intelligence. It won't understand every last, but what you can do is you can map your API to a set of questions and answers, and then that's your interface.
Yeah.
Well, now the one thing Lex won't do, and I'll play our last clip for the day.
Open the Podbay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
So Lex might be able to figure out what you want, and the intent here is to open the Podbay doors. Doesn't mean your API is going to do it. So that's still on you.
Correct.
And if your API goes rogue, well, that's another episode. All right. Well, maybe we should just do one more instead of trying to push through two. Let's do the last one is the EKS Anywhere. But this announcement says Amazon Elastic Kubernetes Service Anywhere now allows you to enable Amazon curated software packages that extend the core functionalities of Kubernetes on your EKS Anywhere clusters. So to give some context, what is EKS Anywhere? Well, it's almost, I mentioned this when we were talking about Panorama. EKS Anywhere allows you to use the Amazon interface to Kubernetes on your own physical infrastructure. And so the packages they're talking about Harbor, which is for scanning your local containers that you're going to run to make sure they don't have any security issues or viruses, that sort of thing. And then there's another one called Metal LB, which is a load balancer that's for bare metal Kubernetes clusters. Now, Raul, you're much more knowledgeable about Kubernetes ecosystem. So what are the implications of this announcement?
So Kubernetes you should think of Kubernetes more as a framework. It's basically an orchestration framework that manages the life cycles of your containers, right? But there is so much more that you need. There are other packages that you need to install for either network layers or different kinds of resources that you want to kind of mount onto that Kubernetes cluster. or have services like load balancers. There are a bunch of different proxies and sidecars that you might want. And so there's just so many things that usually go into that Kubernetes ecosystem. It's never just, oh, I started Kubernetes and I'm ready to go. You need a lot of other stuff that goes with it. And with different versions and different variants of how Kubernetes gets deployed, it's hard to get stuff working right from the get-go. Like you have to be a master at tinkering around with all those packages and the way the installations happen. There are different mechanisms of installing these things. So you really need to be a master at being able to do all of that, and that's hard. What AWS has done here is they've curated a set of packages for you, and I'm sure that this list is going to keep growing over a period of time. But the ones that they have, just install out of the box. They could click, you say, I want this deployed. It's very easy. They make it really easy to get all the stuff working without having to be an expert at Kubernetes YAML files dealing with these particular packages.
So I guess then wrapping up for the time, the 10,000 foot view is that from EKS Anywhere and these packages, you can really have this continuum of usage between your own infrastructure and EKS in AWS, and that really will help you treat them as one pool of resources with the and eventually as your own physical infrastructure depreciates and you may the way most things are going, move more and more of it into AWS. But this minimizes the amount of parallel effort you need to do. You can use Kubernetes everywhere, and then as things start shifting into AWS more and more, it's a much more gradual or incremental process. Would that be a fair way of kind of summarizing it?
I think that's absolutely right. About 90% of workloads today are still on-premise, and there is a shift towards the cloud, but that's again going to be gradual. There's a lot of hurdles to overcome. So the more services that allow you to start at the edge and then quickly bring you on to the cloud are always welcome. They just help more workloads move.
Perfect. All right. Well, I think we're just about ready to wrap up. It's been really fun to just have a big variety of topics to discuss. And Erica, thank you. I know it's been a long session, and thank you so much for your translation. A huge appreciation for what you do. It's phenomenally complicated. So thank you. And thank you to our viewers. Really appreciate it. And we hope to see you next Tuesday, 9 a.m. Pacific time. And yeah, thanks, Raul. It was really fun catching up with you and just having this great chat. And we'll see everyone next time.
Likewise. See you all next week. Bye.
Bye. Thanks.